Alright guys, as a continuation of the example we just started, we're on step 4 in terms of graphing this polynomial. So the next step would be to determine the y-intercept. Okay, in other words, what we're asked to do is find h of 0. You plug in 0 for x because if you think about what a graph looks like, the y-intercept, your x-coordinate, is going to be 0. So you plug in 0 for x and you solve for that. And what you should end up doing, 0, 0, h of x, or h of 0 actually equals 0. So your y-intercept is at 0, 0. So again, now you have another piece of information about the graph, but you also have another point that you can plot on the graph. Step number 5 is simply to find a few more points. And the idea with that is just make a t-table. That's probably the easiest way to do it. At this point, you have your x-intercepts, you have your y-intercept, you have the points that we use to test the interval on. Just pick a few more arbitrary points, plug them into the function. You should be fine with that. And then the last step is to note that the degree of h is 4. Maybe I can spell degree. You look at the leading term here, it's a 4th degree polynomial. So what we know is at most, h can have 4 x-intercepts. We've already determined that in this particular function, h only has 2 x-intercepts, but it could have had 3, it could have had 4, but no more than 4. And with that in mind, that means that h can only have a maximum of 3 turning points. And we said at some point, not too long ago, that when we're talking about turning points, you're talking about where the graph shifts from either becoming an increasing to a decreasing function or from becoming a decreasing function to an increasing function. And if you think about the x-axis, you have at most 4 intercepts. So if it's increasing, it could then decrease or increase or decrease. You have 1, 2, 3 turning points at most. In this particular case, because we determined that our function only has 2 x-intercepts, we only have 1 turning point. It's either going from decreasing to increasing or increasing to decreasing. But either way, you have only 1 turning point in this particular function. So again, there are more examples in the text that it would probably be a good idea for you to look at. I want to reiterate that the steps that you need to solve a function are listed on page 311. And I also need you to take a look at the intermediate value theorem. That is on page 315. That's sort of important as well. In fact, I would almost guarantee that I'm going to put an intermediate value theorem problem on your exam. Again, it's on page 315. And what it says, you can read it plain as day. It says, for any polynomial with real coefficients, as long as a is not equal to b, the function p of a, p of b are opposite signs, and the function has at least one real zero between a and b. So the idea is, as long as a and b are not the same, you plug in a, you get some f of a. You plug in some b, and you get some f of b. Okay, don't forget you're only talking about ordered pairs here. If this and this are of opposite signs, which means if your output is positive and this output's negative or vice versa, then that means there's some sort of 0 in between a and b, which means the function has to at some point cross the x-axis. Okay? That's all the theorem says. There's a few really nice examples. Example 4, there's 4 parts to it on page 315. They're pretty easy to follow if you read the solution. And then again, as always, on page 317, you have the visualizing the graph. Let me give you the answers to that. It is so important to be able to recognize what type of your graph you're looking at. So on page 317, visualizing the graph, the answer to number 1 is H. The answer to number 2 is D. The answer to number 3 is J. 4 is B. 5 is A. 6 is C. 7 is I. 8 is E. 9 is G. And 10 is F. So again, make sure you can recognize your graphs. The strategy for that particular one would be to look at your leading term, to look at the end behavior, and then perhaps to look at what the x-intercepts are, or the solutions, or the zeros, or whatever terminology you want to use to describe the points on the x-axis where the graph crosses. So again, if you have any questions, email me. Otherwise, I think that concludes the material for next week, and then I'll start working on the material for the following week as soon as I get a chance. Thanks.